All right, class. So thank you for joining us, Professor Spack. Thank you for subbing today. I'm not able to be with you guys today. I'm actually traveling. I'm in South Carolina right now. However, learning still has to happen. So today, what we're going to do is learn about fractions. Fractions in terms of what is a fraction, how to add, subtract, multiply, and divide fractions, and some of the rules that are applied to them. The reason why we're doing this overview right now is because fractions are going to play a very big role for us once we get into some of our topics for the remainder of this course. So let's actually start with what is a fraction. So if somebody said to you 1 over 2, this fraction right here, 1 over 2, actually is and actually I'm going to make this just a little thicker so we can hopefully make this just a little bit more, actually that should work for us. If I do 1, here we go, 1 over 2. This is a fraction. What this represents is that somewhere, imagine this is a circle, there are 2 pieces. How do I know that there's 2 pieces? Well, I can see that I've taken this circle and I've split it in half. This is one piece, this is another piece. So let's start with some basic terms that we all need to be aware of, or be aware of. When it comes to a fraction, think of a fraction as a number that represents pieces of a whole. So again, one more time, a fraction, think of it as a number that represents, and helps if I spell it right, that represents pieces of a whole. So what do I mean by that? Again, going back to our example, if I have a circle simply just means that I have an object, such as, let's say, a pizza pie. I have one piece, I have 2 pieces. And once I have these pieces, what it tells me is that I can actually represent every piece in this circle. If I were to split it up into different pieces, I can actually go in and treat this in each piece and represent it as a number. So for example, if I come over here now and I split the circle in half, there's 1 piece and there's 2 pieces. If I split it into 4 pieces, I now have 4 pieces. So how do I represent each piece in a fraction? Well, the way that we do that is through some basic verbiage. If I sit here and say that I have a fraction, the top part of the fraction is known as the numerator. Okay? The top part is known as the numerator, and the bottom part of a fraction is known as the denominator. These are 2 terms that you need to understand because they're going to help us on understanding what a fraction is. Okay, so we know that the top part is known as a numerator and the bottom part is known as a denominator. So what does that mean to me? If I look at a number such as 1/2, 1/2 can be represented as follows. I can look at the number 1 and tells me that I'm dealing with one specific piece. However, the bottom part, the denominator, this part right here tells me how many total pieces are there. So just to recapture that for everyone's benefit, when you look at a fraction, the top part is known as the numerator, and the numerator represents, in this case, the number of pieces that we're talking about at this point in time. However, the denominator, the number on the bottom of the fraction, tells us, in this case, how many pieces are there total in terms of the pieces that I'm looking at. So if I looked at this one little section right here, this section right here can be represented as a fourth. Why? Why a fourth? Because I have 1, 2, 3, 4 pieces in this circle. And each piece here would be represented as a fourth. Again, the number on the top, the numerator, represents, in this case, the number of pieces that I'm talking about. So if I was just talking about one of these pieces in the pie, this one right here, the number 1 represents the number of pieces that I'm talking about, and the number on the bottom, the denominator, the number 4, represents how many total pieces are there in this object that I'm looking at. So let's look at this in a slightly different way. If I gave you, let's say, a candy bar. Imagine this red box here is a candy bar. The candy bar, let's say I'm sitting in a room right now with 3 people, and I need to split this into 3 pieces. So what I'm going to do is simply just split it once and twice, so that I have 1 piece here, 1 piece here, and 1 piece here. Each of these pieces can be represented as a third. Why a third? Because it's one single piece that I'm talking about, and more importantly, the number at the bottom represents the total number of pieces that make up the whole. In this case, 1, 2, and 3. We can look at a fraction as being, again, a representation of a piece of a whole. Now, with that understanding, we have a couple things we have to consider. Let's say, for example, I want to represent a fraction in the form of 1/3. So I have, again, 1/3. What does that mean? That there are 3 pieces total that make up the whole. So if I had another circle, let's say I had an apple pie, and I wanted to take a third away from it, all I would have to do in this case is split the pie into 3 pieces. Again, this portion right here would be a third. This other piece would be a third. And this last piece right here would also be a third. So how do I represent if I wanted to look at 2 pieces of the pie? Let's say, for example, I wanted this piece and I wanted this piece. So one of the questions that you may be asking yourselves, well, how do you represent 2 pieces of this overall pie? Well, how many pieces are we talking about? 1 and 2. So what I can do to represent this is that I'm talking about 2 pieces. However, there are 3 pieces in the whole. So when I talk about these 2 pieces together, I can represent them as 2/3. Again, the number 2 over here represents the number of pieces that I'm talking about, and the number on the bottom here represents the total number of pieces in the whole. In this case, I have 3 pieces total, and I'm only talking about 2 of them. Another example would be if I took another circle and I wanted to, let's say this was a pizza pie. So if I wanted to represent this as a pizza pie, and if typically a pizza pie is cut into 8 sections. So I'm just going to cut it up here into 4 pieces, 6 pieces, and 8 pieces. So I can talk about, let's say, one particular piece of the pie right here, this one right here, this one single piece. If I wanted to talk about this one piece out of all these pieces, well, what do I know? I know that I'm talking about one single piece. And how many pieces total are there? Oops, sorry, helps if I actually do this right. I'm talking about eighths. So what I'm really looking at here is representing 1/8 in terms of this overall pie. If I were talking about 2 pieces, then this wouldn't be, okay, let's rewrite this. This wouldn't be 1/8 anymore. This would be 2/8. Why? Because I'm talking about 2 pieces out of 8. So when we talk about a fraction, think of it again as a piece of a whole. Alright, so what happens when I have fractions, in this case more than one fraction, and I want to add them? For example, if I have, here we go, 1/2, and I want to add it to another half. Well, the good news is when it comes to fractions, there's a very simple rule. And that rule is, take a look at your denominators, the bottoms. And I'm going to highlight this in blue so you can see this. When the denominators in a fraction are both one and the same, in this case, the same exact value, all you have to do in order to, in essence, add them is simply take the number that's on the bottom and just bring it over to the right. When we add fractions and you have the two denominators being one and the same, you don't add them. You just simply take that number that exists in both denominators, in both bottom pieces, and you move them over to the right. What you are adding are the two pieces up here, 1 plus 1, which gives us 2. And anytime that you have the same number on the top and on the bottom, you basically set it to 1. And the reason for that is you can divide the fractions by dividing the bottom into the top. So when you divide fractions, at least, again, this is a general rule when we're talking about taking a fraction that has both the numerator and denominator the same. If you were to divide the bottom into the top, you would end up with the following: 2 divided by 2, which gives us 1. That is why we end up with 1. So anytime when you add fractions together and you end up with the same value on top as the same one on the bottom, just simply divide them and you get ultimately the answer of 1. Now, this works great if all you're doing, in essence, is simply just adding fractions that have similar terms. For example, if I were to add right now, here we go, 2/3 plus 3/3. Again, the key thing to note here, folks, is that my bottoms, my numerators, my denominators are both one and the same. So what do? Again, correct. What you should be doing in this case is saying, I'm just going to add these up, and I'm going to put my 3 right there, because again, when both the numbers on the bottom are one and the same, in this case 3 and 3, you just put the 3 on the bottom. And then we add the two numbers on the top. This can be rewritten as 2 plus 3 over 3, which then becomes 5/3. Another example of this would be 4/5 plus 2/5. Again, my denominators, my two bottoms right here, are both one and the same. So I'm just going to rewrite this as 5 and bring over the two numbers on top that I am going to add, which is 4 plus 2, and this becomes 6. So ultimately, as a rule, when in any fraction that you are going to add and the denominators are both one and the same, you just move it over like we did with the 5 right here, and you just add the top values, 4 plus 2, which gives us 6/5. Okay, as a class, what I'd like for you to do is to add the following fractions together. Number one, I want you to add